Okay, when you have a linear system that's got two parabolas in it, it means that you have two equations that have, the x squared. So if I write those down, and let's write them down in standard form. I'm going to write down an example here. Y equals negative x minus 2 squared plus 3. There's one. And the other one, y equals 2x minus 1 over 2 squared plus 3 over 2. Oh, that's ugly, isn't it? But remember h and k. Remember that h and k give you the vertex of each of the parabolas that are defined by the equation. So in this case, h, k, 2 and 3. Remember, it's minus h and it's plus k. So the point 2, 3 will be the vertex of one parabola, 1, 2, 3 there. We'll call that the blue parabola. I only have two colors. And the other one is 1/2 and 3 over 2. So 1/2 and 3 over 2 is right there. All right. And this is a positive number, it's positive 2, and this is negative. So this parabola will be pointing up and this one will be pointing down. Now, without getting into too much detail, essentially what it would look like is something like this. The parabola pointing up and the parabola pointing down. As it turns out, these parabolas touch at one point there. And how you find that point, you would have to you could either do it graphically or algebraically. And the subject of the next video is on how to do it algebraically. But in this case, if you could graph it, say using your graphing calculator, you would find that there is a point that's common to the two of them, and that would give you the solution to this nonlinear system. But for these two parabola nonlinear systems, there are four possibilities as to how they can look. This is something to go in the back of your mind. The two could look like this, where you have two parabolas that go nowhere near each other, and that means there is no solution set. It could be, like in this example, that you have two parabolas that only touch, they only intersect at one spot, and then there would be one solution. It could be that there are two parabolas that intersect like these two, where you have two solutions, one here, one here. Put that dot there. And it could also be that the two equations represent the exact same function, which would be a real tricky one, sure to show up as a bonus on some kind of a test, where the two define the exact same function so that there's an infinite number of possible solutions. Anything that works in one will work in the other. So to graph, here are the things that you need to do. You need to be able to test a point to see whether it works in both equations. And that's just a matter of plugging things in. You need to be able to graph these. And I think that's it for 7.1. The exercise set is next.